Hello and welcome. My name is Jason Hofmann. I'm head of architecture for Limelight Networks, content delivery network. And I've been with the company about 9 years, formerly heading up product management, and for the last 3 or so years, heading up CDN architecture. With me on the panel today, I have closest to me, Chris Allen. He is the CEO, president, and founder of Infrared 5, company specializing in low latency streaming. And I also have Bill Zurat. He is the vice president of core media at BAMTECH Media, formerly MLBAM, now a part of Disney.
This is true.
And
keep us busy there.
Yeah, and I will let them introduce themselves in a little more detail. So in reverse order now, just to be fair, why don't you give it a start, Bill?
Sure. My name is Bill Zurat. I've been working with MLBAM and BAMTECH Media for a little over 10 years. I'm responsible for leading the core media team. To give you a quick summary, what we do is we are the development team for our encoding software, our packaging software, and also design and architecture for delivery. So we're sitting right there in the media pipeline, and I think that maybe it'd be good to just give a quick overview of how I got involved with all this. It was a curiosity in college, which led to a lot of volunteer work at a nonprofit radio station, which then led me to said radio station being the jack of all trades, from architect all the way down to running cables for acquisition. So it's been quite a ride from the late 90s. And it dovetails nicely because we didn't have fancy terms like D2C at that point. It was 100% listener supported. So that meant that all the revenue that we generated was from people donating from their hard-earned money from their wallets. So quite humbling. But at the same time, it meant that it was a free product that it had to really meet the needs to the consumer. So from there, about 10 and a half years ago, I was hired by MLBAM, and we started the OTT direct-to-consumer product of MLB.TV. And as time went along, we became BAMTECH, and that had a lot of D2C OTT products such as MLB TV, NHL TV. Also, we just recently launched ESPN Plus. And we even have linear space with Sony PS View. So certainly there's a wide breadth of what we've done. Going forward, I know there's been, again, lots of change. We are now a subsidiary, as you just mentioned, of Walt Disney Company. And we are part of the direct-to-consumer international segment right now of Disney. So they're going to keep us busy for a long time. And we look forward to a lot of great work in the future. And I'll just head it off that I know this is about live, but there's going to be a little bit of an SVOD product that people have been reading about. Can't say much about it other than there's going to be some great content on there, and really looking forward to seeing what comes out of that. So I'll hand it over to Chris.
Yeah, so I'm Chris Allen, CEO, co-founder of Infrared 5. Most people know us for Red 5. We were the first guys to reverse engineer RTMP, which is originally the video streaming protocol for Flash. And we created an open source product called Red 5 that essentially became an alternative to the Flash media server that Adobe was selling at the time. Fast forward to today, we've actually kind of upgraded our product to away from Flash, imagine that. We saw a real need for real-time streaming at huge scale, and so that's been primarily a focus now. And we moved our revenue model for the business from a open source project where we were doing services around it, and now we are almost 100% in support and product licensing. So we also partner with Limelight, and we're building out on their network our software to provide real-time streaming at huge scale. And lots of really cool use cases we're seeing that are kind of emerging technologies like How many of you guys have heard of HQ Trivia or know that game or understand kind of the concepts? Yeah.
I played it.
Yeah.
There's Octopi. Anyone know what I'm talking about when I say Octopi? Who was there for that?
But these things are, with a live data stream and a live video, those need to be relatively in sync, because if you're asking a question, the presenter is doing that, or I guess the host of the game, it needs to pop up right at the same time. So latency is a really critical thing for these kind of experiences. We're also seeing it in live auctions, other kind of interesting use cases like military too, where you've got like kind of a panel of different videos, and they need to see all that with the metrics from these IoT devices too. So all kinds of really cool use cases. We're having a lot of fun with it, and I look forward to having more conversation about low latency.
Absolutely. Let's get started. I'm sure you guys are tired of the introductions. I will say that I work with both of these guys, as you heard. BAMTECH is a Limelight customer as well. So you put pressure on me, and Limelight puts pressure on you for new features, and everyone here makes everyone else a little sweaty under the collar some days of the week. And a lot of big events and successes too. So, all right, without further ado, so this is a topic about, this conversation's about low latency, right? When I first heard the term, I thought, honestly, true story, low latency. That's what, like round trip time, ping time? What are we talking about here? 33 milliseconds coast to coast? I mean, what do we mean by low latency? That's such an abuse of the term.
Yeah.
Or is it? Like, what does low latency mean to you? And what should it mean to this audience in the context of video, live video?
Yeah, I think it's a really tough one, because it means different things to different people, and certainly the use case is a big driver of what it means to them, right? So in the case of a live trivia game, low latency means essentially real time. You got to keep that as fast as possible, and I guess we should also define what is latency. So it's the time it takes from somebody like that camera back there to get on a screen here is usually the way I think of it. Is that me doing the?
I've been pretty good, I think.
If you have to, you can just put this on the table. That was the advice given to me to.
Yeah, I think this thing is a little crackly.
Okay, so we should be good now.
All right, sorry about that. Yeah, so end-to-end, like from a camera to screen is what I think of as latency, and the amount of time it takes to get there.
So I've heard the term glass-to-glass latency. Is that what you're talking about?
Yeah.
Is that how you think about it? Like from when the photon hits the camera glass to when it hits your eye, sort of?
Sure.
Plus or minus a picosecond?
Acquisition to the customer. That's like, that's what it generally gets defined. I think that, Chris has some products that he has to, and some problems he has to solve where I think it's like really, really needed to have low latency. I think of anything that's transactional as we, think about it. Any type of marketplace where somebody could, be really hamstrung for, somebody's getting an advantage because they might have a little less latency than the other person is like, really key there. I also think that like, in terms of what, we do for, our solution, a lot of it is we measure ourselves against a different type of clock. The social media shot clock is something that's been, thrown around there. And, when you look at that and you kind of measure against low latency and the consistency of what we want, especially for paying customers, and making sure that that's all cost effective, because the cost is going to go somewhere, whether it's like, someone looking at the bottom line and saying, why did you guys pay that much? Or, maybe the customer is going to get charged more. I think that all needs to get evaluated.
For people in the audience or watching online who may not be sports fiends or Americans, what do you mean by social media shot clock?
So, I mean, there's something that happens, right? Like somebody hits a home run, and eventually it's got to make it through, all the media, different elements of social media. As long as we're not spoiling what's going on, with our streaming, as long as like I should say, reverse that. Let's say that we're not getting spoiled by somebody's messaging. Then at that point, it's like, okay, we've actually beat that shot clock.
So the vast majority of people on social media are consuming that sporting event some other way.
I mean, they could be consuming it on television, which has its own sort of latency. Usually that's
So you want your latency to be on par with television, with the MVPD, with cable with satellite. Is that what you're saying? You don't want to be too far ahead of it. You don't want to be too far behind it.
You've got to be able to beat the actual messaging so people aren't being spoiled. I mean, I'll give you a perfect example of like scores being updated, right? Like when you're watching baseball, you generally don't want to have your guy hit the home run. You're like, it's now I just saw it went to an 8 to an 11. He had a 3-run home run, but like I haven't seen it on my
seen
streaming.
it yet, so I know it's going to happen.
Right, but what we generally do is we'll tie that metadata to the video so that it all like comes in line, so you're not being spoiled in any sort of way.
Right,
so that's like a really important idea of like how you can kind of cheat the latency angle at that point.
I think that's a really good point, is like sometimes, I know there are different approaches to doing this, and one of which is synchronizing the data with the video itself so that people can see it. Have you seen any problems with people being at the games, like the live event, and
I mean, we do
spoiling?
have people talk about it, you know, but it's not as disastrous as something where you see something of, you know, it's more people are consuming on television, and then we don't hear a lot of customer service reports around like people being spoiled at the game, you know, who are telling somebody else. It certainly happens, you know, and I think that the spoiling effect actually I think comes through like different elements. And I know we some things that like we've seen before, it's just like you have people in like a very dense area, and there's different elements of like what's going on within their presentation time of like when they're viewing the stream over time. Right. You know, there's elements of like we don't know. You know, people may not have observed like certain buffering that occurred. You didn't get like the little like death wheel, but something's happening, right? And especially over a long period of time, everybody's drifting at different rates. You know, so that then adds like a little bit of like a spoiler that you're adding latency at that point, and there's nothing you can do about it unless you just hit the fun button to snap back to live. You know.
Gotcha.
There's a common misconception, at least that I've seen in conversations that I've had, that cable and satellite are low latency.
Well,
so I guess it depends on your point of view, but aren't we talking about 10 seconds of latency for cable and 15 seconds of latency for satellite?
Satellite can be a little bit longer than that. I mean, the big thing is to think about like some of the real old guys that like want to really like watch the game at the stadium, and they're paying attention to it with radio, right? Mm-hmm. Like that is the lowest latent like transmission you can have.
Right.
And especially when I come from a radio background, so it's something I'm dearly sensitive to. That it's like people would want to have, for instance, like back in the day, they want to watch TV, but they want to dial back they want to dial back because radio is leading. They want to dial it back and tune it in just right for their latency on their television. And there's reasons for that. There's radio heads that just want to hear the announcer for the radio. But I think that like there's just different definitions for different technologies of where latency is. And then on top of that, there's business decisions where their latency gets introduced. So again, I'll bring it back to like radio when you have live shows or you see sporting programs. And I'm sure some of you may have noticed that like there are times where you just get dead air from a sports program. Well, it's because the guy just got fouled and he just said a foul word. So they have to post-prod that and scrub that out. That's something we can't handle. Like that's from the truck. They're delaying that at that point.
Right.
So we have to be sensitive to that as well. When we're talking about latencies, it's not even an engineering problem at that point. That's just that's a content a decision that gets made.
So let's move off of what latency means and when latency is important by giving examples, and let's move to something a little more structured. I think let's try to segment the space a little bit. So it was recently, actually it was on a call you and I had together where you really helped clarify things for me, but there's a segment of the market that I think we can call transactional, right? Mm-hmm. And the transactional market might include auctions, mm-hmm. Like car auctions or whatever else that happen all the time.
Auctions.
It could include betting, mm-hmm. Gambling on horse races or other things. It could include HQ trivia. If you think about it, that's in some ways transactional. I would probably put it in that bucket. And then there's events that are also simulcast on satellite and cable, which are predominantly but not exclusively sports. It can also be concerts, presidential inaugurations, swearing-in ceremonies, trial verdicts, et cetera. Events that are simulcast that are available on mobile devices and on smart TVs and on other set-top boxes. And before we get into what people in each of those segments prioritize, Are there any other important segments to the live video streaming market that you see with this naive view of segmenting it in the fewest possible buckets in order to understand who cares the most about latency and what kind of latency people are looking for? Are there any other buckets that are important to think about?
I think the offline deployment type architectures and latency, like I was saying, in a military use case or police body cams and other things like that, the latency is critical because there's a communication element with it as well. So that's another transactional style use case.
So that could be two-way video, collaboration, communication, remote monitoring, remote support.
Right.
Okay.
It's kind of more in the video conferencing line, but it also can be one-to-many in the sense that you might have tons of people watching this one feed and giving feedback to whoever's wearing the body cam, for example.
Right. But something about it, whether it's the fact that it's life or death or whatever, something about it makes it critical to have a minimal two-way delay.
That's right.
Yeah, that sounds like a third category to me. Yeah. So let's talk about the first category. I know, Bill, you do less, or probably none of this given your focus, but you can speak about it hypothetically. On the transactional side of things, what kind of latency are people looking for?
I mean, I think that like when we've heard of folks where they would say to some of our product owners saying, well, maybe you have a low latency product, at that point. And then the next question is, what are you defining? Like, what do you want to beat at that point, And generally, like, the bar that gets set is for us is generally like, if people see it as most people are consuming with cable, not doing over the air anymore. So I think that is generally where we kind of see like the bar being set from our customers saying like,
so it's
hey,
that 10-second mark is really
and that's where they consider it to be like low latent, or
what are you seeing,
or even like you'll even hear people who aren't very technical just say, oh well, that's live.
That's live.
Right.
It's not. HLS was always considered to be a near live experience when we talked to some of the folks who were building it. It was never meant to be like, right on the bleeding edge.
Right.
It was always meant to have a little bit of buffering in there. I mean, even when you're dealing with like a radio program, it's not like a news event. So, what we would do is just like, hey, pump up the buffer to like 30 seconds and just like wait there for a little bit. And this was in the 90s, it's like, because, we know things are going to swim around and there's nothing we can do about it because of a single bit rate at the time,
Right. So Chris, for transactional use cases, what do you see as the latency expectation?
Well, our customers, it's definitely under half a second because they want to get it as quick as possible and not have any delay.
That's my experience
as well. If you
could
get it to 0, they would totally take
right.
it.
The latency expectation is as low as you can get it.
Right.
Until I start to run into trade-offs or problems.
That's
just
exactly
as low as
right.
you can make it without breaking things.
And the other thing is I think people have had this expectation kind of coming from Flash. A lot of these use cases came from the RTMP delivery to the Flash player. And that you could actually get tuned down to pretty, much under about a second,
Right.
I mean, certainly using the Red 5 open source, you could do that. In many cases, maybe more like 700 milliseconds from glass to glass, as you say. So what we're seeing is just a lot of people having to take their existing apps and upgrade them to something new, and HLS is not going to do the job. So.
Okay, pretty good. So, and HLS, Apple HTTP live streaming, and Dash, the other chunk streaming technology, same answer, right?
Definitely. I mean, they're both HTTP based. I mean, this kind of gets us into a discussion about protocols, and like if you're looking at doing real time, you just can't do it using HTTP based protocols.
So, I mean, as a stopgap, we work with certain customers where they'll take their recommended chunk duration, Apple's original recommendation of 8 seconds, and lower it to 2, which is actually Apple's new recommendation, and sometimes even down to 1 second. And of course, because the delay behind live when using chunk streaming formats is a function of how much you buffer as well as your chunk size, you can get from 30 seconds of latency on HLS and Dash to 3, 4, 5 by cutting your chunk size down to a second.
Right.
And for many use cases, that's enough. even 10 or 15, and you're on par with cable. 20 to 30, you're on par with satellite. Is that sort of the approach that you're using?
Yeah, I mean, we cut it down to, for a number of reasons, we cut it down to 5 seconds a number of years ago, and we've been happy with that number. I mean, it fit really nicely with some of the DAI, digital ad insertion models that we had, so that was also very important. And you can go into a little bit more about digital ad insertion, when you talk about like why you have to add more latency at the encoder. But I think that we could and we have researched like cutting things down to like 2.5 seconds. What ends up happening though is that you start to play around with these like very small buffers on your HLS clients, and then at that point you might add you might have to add like another chunk in there just to make sure that like everybody all the players are looking good with it, and I mean I don't want to like be flippant and turn it around on you, but like I know that like it's not so fun for you guys to process like 1 second and 2 seconds, right? That's not cool for you. So we generally would work together and say like, well, what is kind of like that nice sweet spot?
What is the optimal?
Yeah, so that like these guys aren't like having all the processing overhead, because I'm sure as hell he doesn't want me to throw out like a 1-frame chunk out there that he's going to have to like process like in these transitions. So
1-frame chunk, that's like motion JPEG.
It happens. You see it with some encoders.
And for context, the reason Bill said CDNs don't like it, generally speaking, especially if you're running 100% SSD-based CDN like we are at Limelight, your bottleneck tends to no longer be the disk. It generally isn't even the NIC, the network interface card, it's the CPU. And requests that come in take some fixed amount of CPU. You have to process the request, make sure it's a valid request, do any kind of security checks, match the customer, match their config, execute any rules they have, and do all of this before you've even started reading bytes from the disk and copying them over to the NIC. And so requests have a fixed cost regardless of how much data is being transferred. And this is why, for example, you see so many CDNs out there, especially ones that let you sign up with a credit card, that can't talk to you to understand your use case. They charge request fees and GB transfer. That way, they can try to keep their margins relatively constant regardless of how big your chunks are or files that you're delivering. It's a long-winded and very geeky way of saying that as you lower your chunk sizes, the CDN's costs go up very quickly. And so CDNs tolerate people going from 8-second chunks to 5-second chunks to 4, but at some point the rate needs to change to accommodate that. And so solutions that don't require teeny tiny chunk sizes are a lot more CDN friendly, right? Because you're making, when you cut your chunk size in half, you're doubling the number of requests the CDN has to deal with, but the CDN is serving exactly the same number of gigabytes. So if you have a pricing model that's only gigabytes, you've just hurt the CDN essentially. And so that's a solution that CDNs aren't crazy about. And there was a huge live event that I can't name, but somewhere between 6 and 12 CDNs participated in this live event on a trial basis. And it was, they were asked to do 1-second chunks, and the majority of the CDNs came back and said, we'll only do it if it's 8-second chunks. And so we were not one of them, but this company was forced to move to 8-second chunks as a result. So that just gives you a sense of how these little things matter tremendously at scale.
So yeah, and let's just walk that out a little bit more. Like Sunday nights, they're big nights. There's a lot of streaming going on.
What happens?
A lot of things happening. Just
Game general. Of Thrones. Oh, right.
There's just it doesn't matter what it. I mean, there's a lot of products that like use Sunday nights. It's just kind
Sunday
of
nights.
like OTT
Sunday
night
football.
Everything. It's just like it hits Sunday night. I mean, we have WWE. It's just like everything. Everybody loves Sunday nights, and so when that happens, now everybody's trying to make use of the same resources. Now we're taxing that, and at the same time, it's affecting the clients at that point. So everybody's swimming, they're buffering, they're stopping, and now we're pushing things back further and further. Now, what did we do to ourselves at this point?
So where does the latency come from? Is it the majority of the latency in any of these cases? Is it when you're encoding? Is it in the packaging, in the turning the stream into chunks?
Let's just, I think that like instead of
Yes,
saying
of
like
course.
it's here,
It's all of the things.
It's everything. Anytime you process something,
Yep.
you're going to add latency. Like there's nothing else
Even
you can
just
do about it.
grabbing the frames from the camera and then encoding it that takes time. And then there's the
Queues in
network
the
layer.
routers are time, right? Everything's
that's
time.
right.
And everything needs to get buffered.
So that was
I
a
mean,
loaded question.
Yeah.
Where does
I know it was.
in the case of chunk streaming, so we're talking about things like Apple HLS, Dash, CMAF, where does the majority of the latency come in the typical case?
Well, I mean, if you talk about what Apple suggested many moons ago, I mean, it was 10-second chunks. I mean, that's just going to, because of the fact that like you got the client on the buffer, right? That's going to have like 3 chunks at least, and then a playhead that's hitting it. So you're just pushing yourself way.
So the
back
client buffer is usually the biggest source.
I mean, right there, that would be, and then as you start shrinking it down, and if you start going to 2-second chunks, now you start looking at different areas where there's latency. Then you're like, well, I've got it equal here, I got it equal here, but everything adds up. Like,
well, I can give you my perspective on that.
You don't get any time back.
So for the last few years at Limelight, we've really focused on getting our rebuffers as low as possible, and focus on just being the quality leader for video. And the metric that most of our customers care the most about, because they've correlated it to customer satisfaction, to abandonment, and to customer retention, and customer acquisition, is rebuffers. And specifically, of the 2 rebuffer metrics that are common, the one that just says, hey, you rebuffered 8 seconds out of 80, that's 10%. The other says, I don't care how many times you rebuffered. If you rebuffered at all, that's a 1. If you never rebuffered, that's a 0. Let me go add those all up. The second metric is called percentage of sessions affected by rebuffers. And I'm seeing that one used more and more and more because it's not skewed by the really, really patient guy trying to watch the game from a basement apartment or from a train dealing with rebuffers every 5 seconds, but he doesn't care because it's his home team. That person might have an 80% rebuffer ratio, skewing if you have enough of those, it skews them for everybody. The other metric, it's unskewed. The only way to improve that metric is to increase the percentage of the population that didn't experience any rebuffers. And so I had a talk earlier today where I talked about how at Limelight we use machine learning to try to improve certain aspects of our quality. And one of the things we focus on was improving rebuffers. And when going through the major causes of rebuffers, lo and behold, it goes without saying, I think for at least half the people in the room probably have day-to-day experience with this. When you make your client buffer smaller and smaller and smaller, you reduce the latency. But you know what else you do? You increase the probability that that user is going to experience a rebuffer. And there's no 2 ways about it. Buffers are the equivalent of CD anti-skip protection back in the Discman days, right? The buffers are there to give you an insurance policy. And if you have a 3-second buffer, you can pretty much only tolerate a few seconds of your throughput plummeting, and now you're behind real time. And now everything needs to pause while your buffer refills.
I hear public internet's not, it's not a perfect place.
I thought you got guaranteed QoS on the public internet, end to end,
perfect.
tracking numbers and everything.
Things happen all the time.
Well, it's interesting you guys talking about this. And in the case of our product and using WebRTC, we basically don't have a buffer. We're delivering as quick as it can, and the latency that we get is really based on the network. From how long it's taken. That's the biggest chunk of time actually that we experience. So.
And if some frames get dropped, There's no point in going and filling them in because people want to see the latest.
Because they want to stay right in time. Yeah, exactly. But there is a user experience kind of issue with that. Sometimes, if you're on a crappy network, you have a lot of packet loss, so you're going to see it kind of do a frame freeze for a second and go back, and continue. So you're basically getting rid of that insurance that you're talking about. That said, WebRTC, is UDP based. It's got things like forward error correction in it, and other ways to actually accommodate and make it smoother for even bad packet loss.
So the error handling for dropped packets in TCP based delivery mechanisms like CMAF, HLS, MPEG-Dash, that all happens in the network stack. That all happens far below user space, far below layer 7. So what you're saying is that when you use a UDP-based mechanism, you can still implement some error checking and correction and some recovery, but you have to do it in the application.
That's right.
And so are you recommending that people go and build that themselves or
Oh, hell no.
use a standard? Okay.
I mean,
I think he can help.
yeah.
Do you have a solution?
Yeah, this is
Oh, you have a
this is why
solution.
we're doing what we're doing, right? Because it is a really hard problem, and we're seeing big demand for this kind of stuff. And yeah, I mean, it's not an easy thing to figure out. I would say, the nice thing about it though is it is a standard. The WebRTC is, and that the browsers are doing a pretty good job of implementing it. Some better than others, but I'm not going to go there.
We don't want to disparage anyone here.
Well, my
Right,
understanding is that one of the things that helped WebRTC take off is that it is the technology used by Google Hangouts
That's true.
for real-time video conferencing with chat on the side and screen sharing. And at least on my computers, in most browsers, I've never had to install a plugin. But I guess there's exceptions to that right now?
Yeah, I mean, so iOS Apple only recently added it, right, in September. So you have to have iOS 11 in order to even get WebRTC on that browser.
But that's still a good sign. I mean, in a couple of years.
It's getting better and better. Microsoft also, they were trying to push another format. Of course, that's the beauty of standards is everybody can have their own, right? So,
So many to choose from.
yeah. But they were doing
what's
ORTC.
The joke? There are 10 standards and a bunch of guys get together in a room and say, we should have one standard to rule them all. 10 standards are ridiculous. And now you have 11 standards.
Yeah. Yeah,
Sorry.
so no, that's fine. And so Microsoft has even had, been late to the game with getting Microsoft Edge updated to support it. But it is getting there, and I think in a couple of years, WebRTC will be ubiquitous and everything will support it.
Yeah, I mean, I think you bring up a good point because it's not something that we could say, oh, here's a product, but you can only use it on a browser and not have it on every other device under the sun that most folks support, with HLS. So that's where it comes really hard to get that solution out there. Now, as more folks start adopting it, that looks encouraging, but unless we can then look at that and then have all the other features that we've grown the product with over the years, that also becomes problematic because people are like, wait, this guy gets this and I don't get that, and there's just it becomes difficult to sell that expectation to people at times.
Right.
So that becomes a challenge, and you definitely have to then have the challenging conversation with your product guy. Be like, but I don't understand. We've been doing this for 10 years. How come I can't?
Education is a huge part of that. Yeah.
Well, we're already, so our two companies are already working together, Infrared 5 and Limelight, and we already have some pilot customers doing WebRTC delivery, and we're getting ready to launch this as a GA offering. Right. And in my experience, at least for the use cases that care about the lowest possible latency, they're fine with the current state of browser and device support.
That's right.
And we're working, I think we have, fall back to using HLS in those cases where it doesn't work.
And even RTMP. So like the browsers like IE and stuff like that, you can fall back to Flash, which actually does a good job of keeping it in real time.
But Jason, when you do the HLS fallback, that's doing a just-in-time transcode, right?
No.
Well, I don't know how he's.
Well, that's our product.
Oh,
So
okay.
I know
Yeah.
how-
Okay.
so-
I'll let you answer.
I thought he was. I was like, I forget that you're now commingled in this. Yes.
Yeah, no, it's all messy.
Yeah.
No, sorry. No, we actually just use H.264 and then basically change the transport. And so we're generating the chunks on the fly.
So it's transmuxing, not transcoding.
That's
You're
right.
doing a mux.
It's repackaging.
Repackaging.
So let's just summarize for everyone, what are the technologies that one can use on the distribution side to achieve low latency streaming for all definitions of low latency, right, across the spectrum, not just sub-second. We have small segment chunked streaming, which is small segment HLS, small segment dash, small segment CMAF. Right. And we talked about how there's a trade-off there. You make your segments small, and it hurts CDN efficiency, and at very large scale may become a concern either on the commercial side. The CDN may say, can't let you do that. Or it may become a capacity issue. All of a sudden, your request for 5 terabits per second prime time might get cut down to 3 terabits per second because you change your chunk size. And that affects capacity, whether most people know it or not. There are some UDP-based solutions that provide a lot of the secret sauce and the magic in the application layer, like WebRTC over UDP, and Quick, which we haven't spent a lot of time talking about. You could still just use RTMP. And
right.
you could either require people to use a Flash plugin, or you could develop your own application that decodes those RTMP packets and displays them, right?
Yeah, and I would also add RTSP into the mix. There's tons of IoT devices and cameras that support that protocol. And we actually use it in our mobile SDK. So we don't even use WebRTC for it because there's signaling involved. There's extra complexity that the browsers need that you don't need if you're just developing an iOS app, right? But that said, the transport itself is still SRTP. It's the same underlying protocol that the WebRTC implementation uses.
Do you know where I still see a lot of, that the WebRTC implementation uses for what?
It uses SRTP too. So the signaling layer is just different than RTSP, for example. So.
I still see a lot of RTSP and RTMP in an industry you talked about earlier, but the online equivalent of radio. So online radio is a very niche market. They care very much about latency. They care very much also about high quality at the lowest possible bit rate, where there are codecs out there that will give you things that sound like 128K with only 32K.
Yeah, like Opus. And,
and Orban and others. And they have no intention of moving away. I mean, they get forced into using HLS in some use cases, but they have custom SDKs for iOS and Android apps. They have custom encoders sitting at the radio stations. They're very, very happy with their 1 or 2, 3 second latency. Most of the latency comes from padding things so that they can bleep out and censor. So I know we're mostly talking about video here today, but that niche market uses a lot of RTSP from my understanding.
Yeah, that's true. And we're also seeing a lot of them move so they can get it in a browser using WebRTC for delivery as well for those.
To keep the latency
audio
you're used
only,
to.
Yeah. See, we have a lot of audio only use cases, actually.
So I know I kind of spoke very quickly about Quick, but do either of you have any experience using Quick as a technology?
We did an evaluation, Google Chrome comes with it by default, so if you load up a Google page, you're going to see some quick transactions at that point.
Right.
So, I mean, there's some, maybe not your CDN that's, been maybe another CDN.
Maybe not Limelight CDN? Okay.
Yeah, maybe.
Maybe not Limelight.
There's been a little bit of, testing going on, testing the waters with it. And, I think that one of the things that makes it challenging, though, is that, until it gets support in the native players, it's a hard sell to put another SDK and just have a pancake of SDKs inside of your box. So nobody wants that. It doesn't taste good even with syrup. So I think that you have to be very cognizant of that, and it's more about looking at the overall ecosystem and see what makes sense. But the results have been great, and for just doing testing for very large bit rates. That's been one of the, instead of latency, that's been something that's going to come up sooner rather than later, I think, is that we're going to start getting beyond, 7 megs, 9 megs.
Especially with 360-degree video and stuff, it starts adding a ton.
4K is going to come up.
Well, that's very, very forward-looking.
So, but we have to. I mean, we're already delivering it on VOD, right?
Yep.
And so I wonder if people, have a hard time differentiating. Let's just put my mother out there and be like, well, why does that product have that, but you don't have it there, and it's a movie?
And they don't get it.
No one gets that. It's just a movie, but you're like, oh, Mom, that's a VOD. I can buffer up 60 seconds. She's like, I don't care. I want to have.
I want it to work.
I want my Marvel movie to be in 4K.
Right.
So.
Have you measured your jitter and packet loss, Mom?
Yeah, no. My mother was a Unix admin in the 70s, so
that she probably has.
So.
She's
long forgotten about all of her, all of her lessons.
Well,
that she learned.
One thing I didn't mention in my intro because I wanted to spare all of you is I also am on an organization called the Streaming Video Alliance, a board member and founding member, and one of the working groups, we have a group that was exploring some of the challenges in virtual reality, and it ended up becoming a working group. And where the industry wants to go is to be able to live stream live events to people's VR headsets or smartphones mounted with VR goggles. And they want for people to be able to look around 360 degrees, not just 180. 180 is great for basketball games, but at a soccer game, sometimes the crazy stuff's happening behind you. That's the joke people like to use. Yeah. But whatever the case may be, you want to look around. And the estimates for the latency required in order to satisfy that use case are ridiculous. In order for you to move your head and be shown something different than you were just looking at and not get sick and not have a black screen for 5 seconds,
what, under 20 milliseconds?
it's on the order of 10 milliseconds.
Yeah.
On the order of 10 milliseconds, end-to-end, glass-to-glass. The alternative is to send the entire 360 image, and when you move your head, it's just real-time cropping. The other alternative is to send more like 180-degree field of vision, and when they detect movement, start grabbing the other 180 that you haven't received. There's alternative after alternative, like send the whole 360 but at reduced quality and only do high quality in the direction that the user is looking, and as you move your head, increase the quality in the direction where they're looking at a delayed pace. So all of a sudden now the pixels disappear. Oh, I can now see.
To really do this right, you're going to have to rethink the codecs
and that's what's happening right now, yeah.
I mean,
just think about the motion. When I've seen these demos and everything, and I start getting motion sickness when they start playing these sorts of games, because I'm generally looking at my complete peripheral vision and everything. So so it's starting to like have this really weird swimming effect that you have, and I'm like,
right.
I'm just like I can't.
And delivering live video with that is an even tougher.
So what people at the bleeding edge want is something that today would require somewhere in the neighborhood of 50 to 100 megabits per second in order to get the full 360 at 4K or whatever it is, or 8K. And it's a cube. You actually have to send 6 sides of a cube, which then get turned into a sphere.
But you can ship that for like, what, 5 people?
Yeah, no, I mean, right, I have Fios gigabit at home, so I'll be good, but my mom will not.
Exactly.
So interesting use cases. I think down the line, we'll probably start to see a little bit more of that. But I think it's safe to say it's a long way away for your average consumer.
I think that's right. I think the other kind of thing that's happening too is just this interactivity with the entertainment for live events. And I see that as a trend that's not going to go away, and it's only getting more interesting. Like, having the ability to, like, we have one customer, it's called Joyride. It's a kind of a HQ trivia type game, but they have it so you can actually play with your friends, and so you're live video streaming with them and then playing as a group. It's like these are really cool things that are happening. It's almost like game shows where the audience members are participating as opposed to just the people on stage.
Right.
Well, I mean, you look at esports and what they've done, and just the type of, consumer that is, that like, that's where somebody's really sitting there, like on their phone, and like they want to be able to like, communicate out and message out what they're watching, and everybody wants to be a part of it, and they even stream like their own, games and everything, just like, just standing it up, So it's an interesting, like space that has really pushed, I think, a lot of folks into thinking, well, maybe this isn't like, your dad's game or your granddad, because people even have a hard time, like, bring back my mother about like, people get paid millions of dollars for like playing video games, and it's hard for understand. But like,
right, esports is a huge.
Esports is huge, yeah.
So earlier we heard from Chris that if latency is what you're optimizing for, you just drop a frame and move on. But when you're using chunk streaming technologies, you don't do that generally.
No, I mean, like,
so what is micro buffering? Can you help us understand what that? What does that mean?
You're going to put me on the spot for something that like you won't be able to Google out there, so everybody will be like, "What is micro buffering?"
Okay, well, what does it mean to you? I mean, it came up in one of our conversations.
Yeah, I mean, I think that like it, I touched on it a little bit, and it's basically the imperceptible buffering events that occur. That if you take, in labs that I've conducted some observation, experiments. I've had like cable TV right next to like 2 of the same devices on the same network, and same all the way around, and I was able to get a clock on to see everything kind of like measure up. Nothing happened, like, and then I took video of that. Nothing happened perceptive, you couldn't perceive it, but things started to slide. So something happened. I don't know what it is. I can't get to it, but something.
So there was drift.
And you get drift over time. Like, fortunately for me, I had a really nice drive by the Packers. Not that I'm a Packers fan, but it was a 10-minute drive, and they just kept the clock on there. So then you could start to see it just add up. So is it a frame here? Is it 5 frames here? I mean, it's 25 frames you're still getting. So I mean, that's cinema quality. That's European quality right there. You're not perceiving anything degrading, but it keeps doing it, and then you start seeing the clocks start to like unwind.
So when people develop players for their apps or for their set-top boxes, or when people download open source players and customize them, I'm guessing they have an option of what to do when there's a significant amount of rebuffering that occurs, right?
Sometimes. I mean, sometimes you might be at the mercy of the player too, So it all depends.
So if I'm watching a live event and it's been optimized, I'm watching a live event, it's been optimized for low latency.
Yeah.
I'm 15 seconds behind live in one of your cases. And either I pause, assuming trick play functionality exists, or it just buffers for 10 seconds. Usually what happens then is I'm now 10 more seconds behind live, right?
Yeah, but I mean, that's nice for you in the CDN because like all that stuff is in the cache. So like you're good.
It's nice for me as a viewer because I don't miss anything, right?
But for low latency, you can jam it and just say like, well, hit the live button. But then other people, they say, well, that button actually confuses me. I don't know why am I.
I don't
off
think
live,
people would get it.
Yeah.
They're like,
so
what?
It's
What do you mean bring me back to live?
Right. So that's part of the.
How do I snap to live? I'm watching something that's
exactly.
live.
So they don't
Is
really
this a time
understand.
machine?
Right. So that gets a little tricky, right? Like you have this where people are like, well, people want to be back to live, and it's like other people are totally confused by that.
I have a snap to live button that I've used many times. It's just refresh.
Refresh. Right.
Because it drives me crazy when I know I'm not live. So
you just gave me a good idea for April Fool's joke,
Yeah.
So, yeah.
Put a snap to live button, but use a refresh icon,
or something like that, or the future. Get them to the future, that kind of thing.
Watch a live event and have a fast forward button there from the first minute. You always have the option to go into the future. All right, so we'll leave a couple minutes for questions at the end. But before we do that, what do people need to worry about on the contribution side to make sure that they're not introducing a lot of latency? And is there a role for technologies like RTMP? Maybe we'll start with you. Is there a role for technologies like RTMP on the contribution side?
Absolutely. I think that most of the encoders, for example, still support RTMP as an ingest format, right?
And that's not dying. That's not being deprecated. That doesn't require a Flash plugin, right?
No, it does not. And it's a universally supported protocol for all of these devices. That said, Haivision is working on a new one, which hopefully becomes an alternative that others pick up as well. But yeah, I think RTMP is still a player. RTSP is as well, even though it's a super old protocol.
Yeah, I mean, we still see like our third parties where we're acting as contribution from our encoders and everybody's RTMP in. I think it's just a little bit of a, hey, we've done it for so long, like this is what works and everything. The other thing to keep in mind too is that like, while we service like a PS view and everything, we're getting contribution from a lot of different sources, and those plants are processing the content very differently. So we're getting like different forms of, so now you can imagine like a class of latency, like this guy's like really super latent, but this guy, maybe he's a little bit better, and like these guys are really great, but you're not getting a nice consistency coming in, so then everything is like, as you're seeing it come through the whole ecosystem all the way down to your client, you're gonna have different notions of like what it is, and there's
like
no
satellite downlink, for example, is probably significant, right?
But like,
I would say
it
even
gets
with
to be
these
problems with like, with news and everything, because you have some programs that are over here and they're like off wall clock from quite a bit of, so.
But even at the very minute, kind of differences, like when you're dealing with sub-second latency, things like tuning FFmpeg to deliver as low latency as possible is actually something that most people don't even think about. Like by default, if you just send out an RTMP stream, it's about 2 seconds buffered. So you have to like really tweak it. And even, if you're deploying like on a Raspberry Pi device, like Chuck at Limelight has been doing for a lot of the demos, he's actually, taken the Raspberry library and kind of done slight tweaks to it just to get everything as fast as possible. But that, that's using RTMP again. But it's not just like RTMP isn't just vanilla RTMP, if you will. You know what I mean?
Right.
Yeah, I mean, it's true. I mean, you can play those tricks and like not that it's a parlor trick, but I mean, it's a real tuning, right?
Right.
And then as you add more kind of messaging and complexity and decisioning and like, down the line, in general, we want the encoder to be authoritative. So, we got to add a little bit of like, look ahead and everything to make sure we're doing the right thing. So we're not like, pounding the packager with like, these really small carpet bomb of chunks. And then of course, the Jason that gets mad at me, for like what happened. So, I mean, there's again, that trade-off there, that you while you're tuning, you want to make sure that you're not breaking another thing. It's a bit of an entanglement that you got to sort out.
Definitely.
So how does, and this is our last question here, how does scale impact low latency streaming considerations? And more specifically, are there any really great low latency solutions out there that you'd love to use, but in your opinion, they just don't scale? And what do you mean by scale?
Oh, yeah. So
I'll let you handle this one.
yeah. Some solutions out there, like there's a company called TalkBox, owned by Telephonic, I believe. It's a product that developers love. It's awesome, actually. It's super easy to use. They got the SDKs. It's a cloud-hosted platform. You can start building your WebRTC apps like really fast. And we love them because we jokingly kind of call them our gateway drug, because somebody builds an app and it starts getting to scale, and then their pricing model doesn't quite work for it because they charge by the stream per minute. And then I think they also offload after about 2,000 streams. They stop using WebRTC and then switch it to HLS, which then gives you the latency problem, right? So I think there's a lot of examples of products that are super good, but they just don't scale right for various reasons. Sometimes it's the pricing, sometimes it's the architecture and how they chose to do it. There's also great open source media servers too, like Janus and that can do a lot of this stuff with WebRTC, but once again, to create a clustering model and have it auto scale and everything else, that's going to be a challenge to put all of that together. So.
Yeah, I mean, I think that like whatever the new technology is, consistency of just how you operate with it, how you orchestrate it is very important. Let's just walk this out a little bit, that WebRTC becomes this sort of standard that we could use. There's no guarantee that like, CDNA is going to do the same thing on a failover for like, how they manage failover than like, maybe Limelight does. So, having that consistency is important because my player guys are going to want to know, how do I recover from this? How do I deal with certain like, conditions?
So you mean if you're large enough to require multiple CDNs, then you need the safety net of being able to fail over from one CDN to another, and if they do things in completely different ways, that complicates your development workflow.
Yeah.
I think that's what's forcing these HTTP-based protocols or keeping it around for so long too, because it is a standard that everybody supports in a consistent way.
Yeah. Well, I happen to know that for a fact. I mean, in the early days, I want to say maybe 2008, we partnered with a couple of big companies to do the Olympics, and it was the very beginning of what later became known as Microsoft Smooth Streaming, but at the time was known under a code name.
Right.
And the whole reason behind using small HTTP fragments with sidecar files that dictated which fragments to fetch and in what order was to come up with something so simple, in quotes, that any CDN could deliver it. I mean, it's just objects. They might as well be images, right? So that was the notion from the very beginning. And now we're dealing with the aftermath of that simplicity, because in engineering, everything's a trade-off. And so the trade-off is what? It's latency, it's complexity, it's fragmentation of the market. It seems to be quite a few things. But on the comment that someone I won't name said to me recently about WebRTC doesn't scale, right. We're seeing something very different in our pilots right now, that I think when you deploy it in a CDN, and you tweak it and you optimize it, we're not seeing those kinds of issues, and so that's the good news there.
It doesn't scale if you don't want to put in the work. I mean, that's the truth. It's very complex to do it right.
Any closing remarks before we go to questions?
No, I mean, I think that this has been really great. Thank you for moderating and everything for us, Jason.
Yeah,
So
I agree.
mean, and thanks for coming on. And it's always good to even come to these things. I sometimes say I don't get out enough. So I hope this is a way of being able to be with our peers and be able to talk about these things. So thank you for.
Yeah, likewise. Thank you.
All right. So you're welcome, by the way. Let's take some questions from the audience. Yes, please. I know you are.
So, I perfectly realize that the whole idea about chunk HTTP delivery, like HLS and Dash, is for the simplicity and that every CDN can support it. But what if we were able to just a little bit change it so that you could still have the granularity of maybe 1 second, but save all the requests going to the CDN? For example, if you could ask a request for that chunk, but in return get the next 8 chunks for a single response.
Mm-hmm. So I'll repeat the question or summarize the question. Ori said, I understand that these chunk streaming protocols were developed in order to be simple and compatible with just about any cache you could dream up. What if we could tune these technologies somehow so that we could still get the granularity of just having 1 second chunks, which in turn would translate probably to 3 or 4 seconds of screen-to-screen latency, but without having as many requests, right? So going from 8 to 1 normally would mean 8 times as many requests. What if we could do it without 8 times as many requests? For example, and then I think I missed that a little bit, but is it just by having the server automatically send all the remaining chunks?
Chunk encoding or something like that. Of course, we need to support it on
Right.
both sides, but
So without getting into our customers' proprietary optimizations, I can tell you that we have worked with a number of customers to implement similar things, probably starting as early as 2006, where, for example, rather than actually requesting chunk after chunk after chunk, you maybe make an open-ended range request, which uses the range header, a byte offset, a dash, but no second byte offset, which just says, just keep giving it to me until I reset the connection. There are optimizations that can be done. We have technologies that allow us to grab the range from the URL, so you can create a manifest file that allows us to cache one gargantuan file on our side, but serve it up to you in chunks, which optimizes and makes us more efficient in other ways. Because caching one big file is better than caching lots of small files. And so we generally work with our largest customers to come up with exactly those kinds of optimizations specific to their use cases. But the industry as a whole hasn't, I don't think. So the biggest customers tend to get the benefit of these custom tweaks or of these slightly off-book but still standards compliant optimizations. But to your point, I think the subtext was, as an industry, can we solve this? I haven't seen moves in that direction, but I also don't participate in any of the relevant standards bodies. So if there is movement in that direction, I probably would not be the first to know.
I would also think there's probably diminishing returns at some point, right, where you're trying to tune it down to a 3 or 4 second latency, but then, like, why not just use WebRTC if you're trying to get it that low, So.
Yeah.
So to me, the thing is that what happens when you have disruption, with that. So you got to be able to account for it. Then clients are going to have to agree on things. It's not a perfect world. At that point, So it's nothing's impossible, but these things always need to be thought of.
Right. Well, I want to be fair to the event AV team and all of you guys. I need to let you know it is beer o'clock, and so. Feel free to get up and leave, but if there are 1 or 2 more questions, I'm happy to take them.
Hi, Red 5 server.
Yep.
Guys do WebRTC and you provide RTMP playback?
Yes.
Let me repeat the question.
Oh,
this
sorry.
question is directed at the.
Sorry. The question is now, is it licensed or do you do it as a service?
Okay, so let me repeat the question. For your WebRTC offering, is it licensed or do you do it as a service? Or in partnership with Limelight? It's after 5. I can lean back now.
Yeah, so it's a licensed model, and we do monthly recurring kind of, or yearly recurring. Yes. Yeah. And then we also have an awesome partnership with Limelight, as Jason mentioned. So.
Cool.
Any
I think
other
we're good.
questions?
Oh, well, last question. If you have more, you can come up after we unplug.
You mentioned that scaling WebRTC is complicated. What were the complexities that you ran into at scale in a non-vacuous way?
ICE negotiation and signaling. You got to maintain basically a TCP channel to actually set up the connections. So getting that down to as low of a connection time as possible is really tricky. And then how do you spread it across a cluster? You know what I mean? So we have like an origin relay edge kind of model, right? Which is pretty typical for these kind of setups. But then at the edge, it's doing a lot of stuff to like keep it in real time, and then you have to manage. The other thing is CORS headers that the browsers enforce.
CORS, so that's cross-origin resource sharing?
Right, exactly. You can't actually connect to a site that's not secure, so you have to have domain names for it and HTTPS. The page you're pulling from has to be there. Then you also have to have the media server piece or the edge server actually know about that site. So adding that, and when you're like a company like Limelight, you have a ton of customers all trying to use the same infrastructure. How do you get those CORS headers on each of the edges? It's just,
So the biggest metric we're trying to optimize for with our WebRTC deployment is the same as what we do with anything else, which is how much can one of our servers handle at excellent quality. So we might need to take it, not even ballpark numbers, totally made up numbers, but we might need to take something from being able to do 1,000 concurrent streams per box to 10,000 in order to have
make it
something
worthwhile.
competitive,
Yeah.
something that we can price at a reasonable price that people will want to use.
So that's definitely another
That's
one. Fine-tuning.
The biggest metric for us.
Fine-tuning the performance so that you can get the most out of a CPU and RAM as possible. That's some serious work to get done too.
And we did the same thing for our CDN and our caching over the last few years as well, which improved quality and increased capacity at the same time. And the way we did it there was the traditional way. I mean, you can read about it. Netflix has blogged a lot about that, but the way we did it on the CDN side was on cutting down on the number of memory copies, which is traditionally done one of two ways: move everything into user space or move everything into the kernel. Avoid the kernel user space boundary. All right, well, thank you all for coming. Thank you all for staying overtime.
Thank you.